This is IAT806, Lecture 6, Objects and ArrayList. So what we're going to be talking about today is the use of a new facility to the course, which is something called the ArrayList. It's a special kind of array that has a lot more facilities than the basic, straightforward square bracket arrays that we have been using so far in the course. However, there's some things that a facility like ArrayList needs in order to function correctly. So we're going to be talking about those requirements that are based on object-oriented programming techniques, and we're going to talk about those as we move forward now. So to get started, what we're going to be talking about is programming concepts first, including two new Java keywords. Well, one new, one used, one reused already, super and this. In the context of that, we'll also be talking about the Java Software Development Kit classes, such as lists and ArrayList, as I said earlier. And we're also going to be just making reference to the Java documentation that's out there. And that will be the formal piece of the lecture that we're going to be talking about today. So to revisit our example, we've been talking on and off throughout the latter part of the lecture series about an implementation of the Asteroids, the classic video game Asteroids. And the way that classic game works is that there's a little rocket that moves around in a black field. And the way the game works is that you can fire missiles at asteroids. When a missile hits an asteroid, it blows up. And in the original game, a big asteroid became two smaller, medium-sized asteroids, and then if you hit a medium-sized asteroid, it would break into two small asteroids. And if a missile or a bullet hit a small asteroid, it would disappear, turn to dust. So we're going to implement elements of that for our running example, with the exception that there's only big and small asteroids in our case, and it's got certain limited facilities. So for the example purpose of this lecture, we want our missiles to blow up asteroids. Right now, if you recall, we have asteroids that are stored in an array of fixed size. And that means if we're going to blow up asteroids, we need to take them out of the array. We can't draw asteroids that are not there, and we need to be able to deal with that problem. So how do you deal with this problem of making an array lose some items? Well, there are a number of approaches. So what I'm going to do now is pause for 5 seconds where we talk over the possibility of how can we do it. So hopefully you use that enormous 5-second gap to think about it. But of course, during the lecture period, we stopped the video so that we could have a discussion. So one of the topics that came up is possibly that you could create a special kind of class or something that is stored in the array list whose job it is to be empty. I am, an empty asteroid, in which case draw me does nothing. Another variation on that class is to store 0 in an array element, and 0 being kind of the standard marker for a reference that points at nothing. You could then use that to say, I have an empty item here, so don't do anything with it. Or I could do a third broad approach. Instead of specially marking an empty array element, is I could have a high watermark for the number of elements that are stored in an array, and every time I add an asteroid, I increase that high watermark to say now there are 3 asteroids, now there are 4 asteroids, now there are 5 asteroids, etc. And every time I delete one, I move I mark the one I want to get rid of, and I move all the ones above in the array down by 1 to fill that empty spot. I then have an empty spot at the top, and the way I deal with that is I set the high watermark to be down by 1. If I then want to create 2 new asteroids from one I deleted, I add 2 and increase the high watermark. So that's a classic technique. The drawback with that technique is it requires a bunch of extra bookkeeping. You need to have a spare variable whose job it is to say how much is in here. So instead of doing that, what the Java Software Development Kit does is it provides facilities for that kind of activity, because having arrays with a flexible amount of stuff in it is a standing problem that lots of people confront when they're building programs. So what we're going to do is talk about ArrayList, and we also need to figure out how to have a collision and use that to manage the content of however it is that we're storing things. So as I said, we have this collection of stuff, and we would like to put it in this ArrayList construct. Where does that ArrayList thing come from? Well, it lives in or is presented to you by the Java Software Development Kit. So Java comes with thousands of classes in the Java Platform API, or Application Programmers Interface. An API is a kind of a general term that people use to denote a collection of software that has a well-understood means of accessing that software from program code. So Application Programmers Interface, we are application programmers using Java's facilities in the Java Software Development Kit, using the Java API to access the facilities of ArrayList and other types of things that we will find useful. We've kind of quietly been using Java Software Development Kit stuff all along. We've also been using the API for doing graphics within processing without saying overtly APIs are in play. If you want to get more documentation for the Java API, you can get more documentation for that stuff from Oracle's website, and point your favorite search engine and type in Java and then say the object name or the class name, and you'll get some documentation. And the documentation is really aimed at people who know how to do programming. The documentation is how to use this particular little piece of software. It's not about the philosophy of doing programming. That's, because otherwise, if you were to put the philosophy in every piece of documentation, the documentation will be unreadably large. So what we're going to do is take a look at ArrayList as the motivating example. So what ArrayList does is it's a resizable list. It's an array. Behind the scenes, there's some kind of array stuff going on, but they don't tell you exactly how it's implemented, so that if they want, they can change the implementation, and we as users of the software are none the wiser, because it doesn't matter how it's done. This resizable list, in that list, you can add and delete things without worrying about saying anywhere what size it is supposed to be. That's a facility that it does for you. It has some performance impact anytime resizing happens. Sometimes the performance impact is nothing, but other times there's reason, you get a little bit of delay when you're using it. And the main methods that you use to access an array list are things like add, get, remove, and size. Size is a query thing. It tells you how big, how many items are in the array list. Add is the thing you use to add items. Get is the way in which you retrieve items. And with get, it needs an argument to say which item. Remove allows you to remove the item. And size, of course, once again, tells you how many things are there. So the steps in using an array list is, first you declare a variable of type ArrayList. So ArrayList, it's a class, and so therefore ArrayList is the type name. ArrayList, AL for ArrayList. And then you create that new array list, you allocate it, you do equals new array list, and then you simply call add on that variable, al.add something, and that adds the something. The something in this case is class instances, things like, you can't use things like fundamental types like float and int, because it's not only built for, array lists are only built for storing objects. So you just add, you get, you remove, and as you need, you query size. You do need to query size if you're using a loop to iterate through the list. You need size for that, so that's where you do it. So to enable that kind of technology to work, there is some object-oriented terminology and abstractions that you need to be aware of in order for that to function. So we're going to take what seems like a little side trip around this question of parents and children. I don't mean human beings, but what I'm talking about is hierarchies of classes. So remember that we declared the child class Armed Rocket, and it had as a parent class Rocket, and the technique for that was class Armed Rocket extends Rocket. Okay, so we already had Rocket defined somewhere, and we created a subclass or a child class named Armed Rocket, and the reason why we know that is we said class Armed Rocket to declare the existence of the new Armed Rocket class, and extends Rocket, which says this Armed Rocket thing comes from Rocket. So each class that we declare or is declared for us elsewhere is a type. So Armed Rocket is a type and Rocket is a type. We've seen that before already. So right now we can show what are some legal valid assignments: creation of a variable, and construction of an instance of that object. So here we go. So armed rocket. Oops, sorry. Here is the first line here. Armed rocket R1 equals new armed rocket, and we're just using the X, Y, and orientation arguments in its constructor. So that says there's a new variable named R1, and its type is armed rocket, and what we're doing now, that's the declaration of R1, and we assign it its value, and that is to construct an instance of armed rocket and assign that new armed rocket to R1. So far, so straightforward. The next thing is also legal, and it's exactly the kind of thing you would expect. Rocket R2 equals new rocket 5060. It's going to end up at the same location, but that's not important. What I'm pointing out here is rockets get assigned to variables of type rocket. Armed rockets get assigned variables of type armed rocket. Here's the fun stuff. So in the green, this third one here, it says rocket R3 equals new armed rocket. So that's interesting. And this is one of the features of Java programming. And that is you can assign variables of the parent type instances of a child class. So armed rocket is a child class of rocket because armed rocket extends rocket. So therefore, an armed rocket is a rocket. So that formulation is very important in object-oriented programming. It helps you kind of understand the relationship. So because armed rocket extends rocket, as we recall from the other day and I just said, an armed rocket is a rocket. It has all the facilities of rocket inside it. Okay, so therefore, assigning R3, which is of type rocket, a new instance, which is of type armed rocket, that's legal. That's cool. We can do that. And that's going to be useful further on. However, this fourth thing I put in red, it says, but this is illegal. Armed rocket R4 equals new rocket. It would seem that maybe they're related, they're friends, we can do this, but we can't. And the reason why, it's because when you say variable armed rocket R4, that variable is expecting an armed rocket. If we assign a rocket to that, there are some things that armed rocket has in it that rocket doesn't have. And how do we know that? Well, because armed rocket extends rocket and it's got stuff in it, even if it just has a new constructor. And there's no point in creating something like armed rocket to extend it and then do nothing. Although, just maybe as a stub, as information to be filled in later, but most of the time you're doing a derived class for a reason, because you want to add new stuff. Well, Java doesn't know whether you're adding new stuff, and instead just declares this thing to be this kind of assignment that won't work because the types are wrong. So a rocket is not an armed rocket. The is-a relationship goes in one direction only. That is to say, a child class is an instance of its parent class and not the other way around. Let me show you a visual example. I flashed this up for a moment, but then I was moving ahead too quickly. So here's rocket up here. That's the parent class. And it has a bunch of fields: x pos, y pos, x and y velocity, rotation, and there's its construction and its drawMe function. Okay, so far so straightforward. Armed rocket extends rocket, and the inheritance direction points upward. Child points up to parent. Okay? Armed rocket extends rocket has the same fields with probably some more stuff like last raw millers or something. And armed rocket is a new constructor with a new name that's the name of the child class, and this new method fire. So if you wanted to say, assign something to armed rocket, assigned construct a rocket and assign it to armed rocket, that variable R4, going back one slide, going back one slide, there it is. R4 would expect to have a fire method, but it doesn't. And because of that potential problem, this kind of assignment of assigning child variables with parent class items, that's not legal. Okay, let's move forward. So this is kind of illustrating both visually and in text the kind of rules and regs about what is going on. So let's move forward on to the next slide. So the reason why we're talking about this is because the main parameter type of adding objects to the array list, the parameter type for the add method is actually object. Object is the parent class of all classes in Java. And what that means is that there's a class hierarchy in Java. At the top is object, and descended from that or extending from that are some other classes, and further what extends from those intervening classes is Rocket, and what extends from Rocket is armed Rocket, as we've shown in the previous slide. So with an object argument type, you can pass an object of any class. There's some small problems to deal with that, but we'll just deal with that as we move forward. So to initialize our asteroids, here we have an array list named asteroids. Okay, so the type of asteroids is ArrayList, and then we're constructing an array list. We can just simply construct it without any arguments in its constructor, and we'll get a default size array list. And then what we're doing here is iterating through the number of asteroids that we plan to have, and doing Asteroids.add new asteroid. And here we're just constructing 5 randomly located and oriented asteroids. The actual type that is being inserted into the array list is actually object, because what happens is the parent class is the top class object is what's happening there. So the next thing we would like to do is we would like to be able to, once we've filled the array list, is to get objects out of the array list. And as I mentioned earlier, we just execute the asteroids.get method. And what that does is it returns an instance of something. It returns the ith object. So asteroids.get, and then you have some integer value from 0 to 4 inclusive, and it returns the ith object, starting once again with 0. However, if we were to do this, asteroids.geti.draw, where what we are anticipating on being able to do there is asteroids.geti returns something, and which we hope is asteroid, because that's what we put in the array list. And if we attempt to call draw, or draw me, on it, what we will get is some kind of error. In fact, that error is marked at compile time because there's a type mismatch. So let me now explain why. So what happens is, because we are putting asteroids into the generic array list, what we are actually putting in there is objects. Behind the scenes, there's some information stored in each object in Java, some information about what the class type is. But on the programming side, it's as if when you insert an asteroid into this asteroids array list, it kind of forgets what type it is. Since things are put in the array list as an object, they come back out as an object. They forget, as I said, the more detailed type. So when using ArrayList or any other container class, and we'll say what that means later on in the term, you need to do something to transform the type from object, this totally top-level class, back to asteroids. And you know that'll work because, of course, the outcome of this activity is we've passed asteroids in, so we can cast it back to the class. So here's the syntax to do that. So we're creating a new variable, just to make it concrete, named ast. And what we're doing is saying, issuing the method called asteroids.get get the ith asteroid, and that returns an object. And this parenthesis asteroid does what's called typecasting, which transforms the type of the object to the type asteroid. Now, of course, it has to actually be of type asteroid or something in order for that to work correctly. You can't, sort of put in strings and have that function correctly. That'll just fail at runtime. So given that we assign that now cast asteroid to the ast variable, we can then say something like, if not ast collision with a rocket R1, if there isn't a collision, then we should draw it. So doing this typecasting here with asteroid to asteroid, and then we can do asteroid calls on ast. Okay? So another way to go about doing this is to specify when you create the array list what type it holds. And that is to say, when we're creating a variable to hold an array list of asteroids in our case, we need to say what the type of the variable is twice, right? The first time we need to set type is for array list, and the second time is to say that it's an array list of asteroids. As you can see in the text below, here's how it's done. You first specify array list, and then in what's called angle brackets, or the less than and greater than sign, you then specify what type that this array list holds. So this kind of double typecasting is what we're trying to do here. So we've changed the variable name just to distinguish it from the other asteroids containing array list. So array list angle brackets asteroid rocks equals new array list asteroid. So we specify the second type asteroid in both the specification and the declaration as well as in the construction here. And now what we can do is once again do this iteration through a loop to create num asteroids, number of asteroids. Do rocks.add equals new asteroid. That's just like before, except it's now rocks instead of the asteroid array list. And now we can do rocks.getI.draw. And the reason why that works is rocks is an array list of asteroids. GetI returns an asteroid, and draw is a call that you can run on an asteroid. So that means that the types are all correctly aligned, and we can chain these calls together. This act of chaining one call after another with this dot notation is something that enables us to succinctly express a number of activities in a row if there's no intervening computation that needs to be done. And just as an amusing side issue, there are asteroids out there in the real world, of course, and a Japanese spacecraft visited this asteroid here named Ryugu on September 18th, 2018. And here's a picture of the asteroid Ryugu that it visited, and you can see it's kind of a rough surface. It's not round. It's small enough that the gravity is not so strong that you get these funky shapes. So there's some proof that we know what we're talking about when we're talking about drawing asteroids. So just a little amusing side moment. Okay, so one of the things that you do in the asteroid video game is you collide asteroids with things. The thing you want to collide asteroid with is missiles. You can also collide it with your ship, but that's not what you want. But in the game, you still need to test for it. So now what we're going to do is talk about where to put collision detection. As in most elements of object-oriented programming, you have this little problem of what happens when objects need to interact with each other. In this collision detection thing is one of those classic needs for interaction that we need to deal with. So you could do collision detection in draw, the main setup and draw, the processing draw function. But the problem with that is that the information about the shape of rocket and the shape of draw or the shape of missile needs to be in the draw method, and that seems kind of a mess. To take all that information out of the classes where it lives and do it, sort of in the draw method or in setup. Although you would need to call it every iteration for draws because objects are moving around. But in any case, the right place to do it in an object-oriented program is in one of the objects, perhaps needing to access information from the other object. And that's the approach that's taken here. So it's cleaner and more object-oriented if Asteroid itself knows how to detect collision. That is to say, the information to reasonably compute whether a collision has happened between two objects is in at least one of the objects, perhaps getting information from the other object that is potentially colliding. So detecting collision depends on knowing the boundaries of the asteroid, and that information is in the asteroid class, so that's where that information should be and where it's more closely located. And I'm mentioning this kind of elaborate reasoning for the purposes of helping you figure out, where should I put something? And typically the right place to put something is in the object that is involved in the computation, so that the information about that object stays within the object as much as possible. So because we're just suggesting a rocket colliding with asteroid in this example, we have a Boolean method named collision, and it takes as a single argument a rocket R. So it's expecting as input the ability to test whether a rocket is colliding with the asteroid. And here we have 4 if tests, and all of these things need to be true in order for there to be a collision. And that is, if I may draw, using my head as the asteroid, the rocket needs to be on this side of the, the left boundary, and on that side of the right boundary, and on above the lower boundary, and below the upper boundary. Okay, so that's what we need to have happen, is the rocket needs to be within those 4 boundaries. Forgive me if I mixed up left and right. So you can see in this sequence of conditions here, we're ANDing all those things together. And this thing, double ampersand, is a Boolean operation that expects a Boolean expression on the left, which is less than or equal to, and a Boolean is greater than or equal to, rather, and another Boolean expression to its right. So these things have to be true, and this has to be true, and that has to be true in order for there to be a collision. These numbers 26, 22, 24, negative 24, and positive 26, those all come from the minimum and maximum x and y values in the geometry of the asteroid. And that information is baked into the asteroid code, so it's just simply repeated here. If the asteroid was smaller, we'd use smaller numbers. If we didn't actually take some care to record a minimum and maximum value in variables or something like that, so it's located here. The other approximation we're taking was we're just taking as the rocket's location x pos and y pos. We're not computing the actual extent of the rocket in x or y. We're just using the center as a stand-in. So sometimes it's possible that if the asteroid itself had a big concavity in it, that the rocket would fit in the bounding box but not collide with the asteroid. But it's unlikely, so we're not going to worry about it. As I said, if it returns true or false if there's a collision. So when a missile hits an asteroid, we also need to destroy the asteroid. And just like in the video game, big asteroids become too small asteroids in our variation. In the video game, there's an intervening size where we're just ignoring that for this code. So the whole reason to use the ArrayList, of course, was to have a variable number of asteroids on the screen, and those are stored in the ArrayList, rocks or whatever it is. So what we're doing here is we have this destroy method that it doesn't return anything, it's a void, and it takes as its argument the container that holds all the asteroids. Now, the reason why we're doing this is because what this method does is it adjusts the contents of the container. And what we're going to do is this method is called on the asteroid that we want to destroy. So we've seen a collision, and then what we do is if this asteroid has collided with a missile, we will then call this, this asteroid .destroy, and we'll pass the container to say, take it out of this list that it lives in. So anyway, so here's how we're going to accomplish that. First, we take the container with, which is typed to be asteroids, and we just say asteroids.remove, and that's the remove call for in the array list, this. So what is the this thing about? Well, that's a Java keyword whose job it is to refer to the object that this individual method is running in. It's as if in this code, the code is pointing to itself in some sense. It seems a little circular, like the snake eating its tail, Ouroboros. But really, what's going on is you need a method a means to refer to your own object, and the keyword this is the means to do that. So the first thing it does is removes this from the array list. That doesn't mean that this asteroid disappears immediately. It just means that it's no longer in the array list. The next thing that happens in this method is if it is large, if the Boolean is set to be large, then it adds 2 new asteroids located in the same place, and there will be a random orientation or random velocity associated with that, and adds those to the list. So we see Asteroids.add and of essentially the same call twice. We're just creating a new asteroid and adding it to the asteroids list or the rocks list. So what that's doing is removing the old and adding to the new. If you're doing this collision detection in a loop, you need to make sure that the boundaries of the loop are actually using the array list's size as opposed to some fixed number. Because if you use a fixed number, sometimes something unfortunate can happen. And the unfortunate thing that can happen is that you could go off the end of the list. So you always need to test for the proper array bounds, and the way to do that is to instead of testing num asteroids or something like that, what you need to do is check against asteroids.size or rocks.size, whatever it ends up, whatever the variable name is. So we have seen super before, and that was with respect to calling a parent class's constructor. But super and this are both special Java keywords, and their job is to refer to elements of my own class hierarchy, just to anthropomorphize a bit. This is a special variable that always refers to the current instance of the object. And it's used in special cases like we showed here. And sometimes if you have the same variable name as, you have a variable name in a field and you kind of reuse that variable name as a method parameter, this dot variable name is referring to the field, whereas just the bare parameter name inside a method is referring to the method's parameter variable name. Similarly, if you declared a variable inside the method somewhere, that declaration, if you reused the same name as a field, that variable declaration, it hides the other one. And so if you want to get at a field name, you say this dot field name. So this is a special variable that always refers to the current instance, and it explicitly enables you to access fields, methods, etc. of the class that you're in. It's useful in some methods occasionally to refer to your own class instance. And this dot method calls a method on yourself. It might be a means of calling a particular method that you have you're intending. And this, without an intervening method thing, is a means of calling a constructor. And you would do that within one constructor, typically to call another constructor that typically has more parameters. Because inside a constructor with 0 parameters, you might call another one that has a bunch of parameters. The information you call that with is hard-coded values. So the no parameters constructor has a bunch of pre-computed starting values, and then you just simply call the more parameters constructor from the 0 parameters constructor. And the way to do that is by saying this, with a parameter list. It's just a way of referring to which thing. And you have to do it by saying this and not by calling the constructor directly. Super, we've seen before, is a special variable that always refers to the super class portion of an object, and the object is cast into that superclass and some work is done on it. And you can say, let's say you have a child class that had some methods and the parent class has some methods, and you want to use the parent class's method, you say super.method, and that gets the parent class's method. And if you have a child class and parent class and they both have the same method name, when you run it, you by default get the child class's one, on a child class variable. So super is a way to explicitly say, I want the parent class's method. Super without without a method, the super open close parenthesis, that is calling a superclass's constructor, and we'd actually seen that in the armed rocket example. Okay, so in summary, what we've talked about today is we've talked about how to use the ArrayList, our first Java platform class. We've learned about super and subclass as types, and we need that super and subclass stuff to be able to do the magic that ArrayList allows us to do. ArrayList, you can store an array list of anything, a whole bunch of asteroids, a whole bunch of rockets, a whole bunch of missiles or whatever it is, and you don't want to have to rewrite ArrayList for all that. You just want to use the same technology for all of it. That's really what you hope for. That's one of the things that object orientation is supposed to buy you. And doing it the object-oriented way is much safer than doing it in C. You just hand pointers to chunks of memory, and that was kind of a mess and cause of errors all the time. This is a whole lot more clean way to do it. So anyway, and we've been telling you about this. And it's the class hierarchy that enables this generic concept of ArrayList to be used all over the place. So any instance of a subclass is also an instance of a superclass. That's one of the techniques that allows the ArrayList to do its thing, but not vice versa. And so typically, if you want to have access to the way something works, you would use a parent classes method. You can also cast more abstract or higher up the class hierarchy, cast more abstract classes like object to child classes like Rocket or ARM Rocket, even more detailed class or more child class, or here what I'm saying is concrete classes such as children. We also spoke of the Java keywords super and this, and these are special variables that can be used within a method to refer to itself or yourself, and or in the case of super, to the superclass portion of this object. Okay, so that's about it for this lecture. I hope you enjoyed it, and that's the end of IAT806 Lecture 6.